Dartmouth College begins its third century of service to American education, still regarding its essential function to be the maintenance of a free and honest marketplace for the exposition, exchange, and evaluation of ideas.
At Dartmouth, we have been engaged in an experience that represents the cutting edge of a new social revolution. I'm referring to our 4 years with time sharing. To give you an idea of what this revolution means, let me tell you about another revolution. About 125 years ago, men started to use steam engines to lift coal and to lift water out of the mines so they could mine for coal. Today, if you want to lift a ton of coal from the ground and put it on a wagon bed, say 3 feet off the ground, you can buy the power with which to do this for about 0.8 of a cent. That's why no man can earn a living today just lifting coal. Now, in the last 25 years, we have developed a fantastic capability through digital computing, and in particular with time sharing, we make it possible for any man to do about 1 million logical operations for 8 cents. And through time sharing, we mean any man.
Today, approximately 85% of all Dartmouth undergraduates make use of the computer. Students in more than 100 courses, ranging from the sciences and mathematics through economics, education, and psychology, to languages and sociology, make direct use of the system in completing course assignments.
Two things combined to thrust Dartmouth right into the middle of this new social revolution. The first was our ability to use the GE computer that was capable of being time shared. The other was the development of a new simplified computer language, so simple that it could be taught to grade school children in about an hour and a half and to adults in about 2 hours.
The system now in operation at Kiewit Computation Center can be used by up to 150 people at one time. It is functioning as an education information utility, serving Dartmouth College and 36 secondary schools and colleges in the New England area. Here's how it functions. A teletypewriter terminal, any or all of the terminals, is used to send questions or programs over ordinary telephone lines to a DataNet 30. When the message is complete, the DataNet forwards it to the large-scale GE 635 computer. The answers are then sent back to the DataNet 30, which directs and controls the back and forth flow of information traffic. The students can also draw on a growing library of programs and the vast amount of data stored in disk memory files. Both programs and data are constantly available for direct fingertip retrieval at any of the terminals. Working together as a system, these devices give each user the illusion that all are working for him exclusively. The electronic elements function so fast that there is computing time to spare and share with hundreds of other students who use the now famous basic language first developed here.
Mike, you were wondering how you could use BASIC to calculate the ratio of students and faculty at Dartmouth College. In order to do that, you have to prepare a program in BASIC. Let's take a look at this program that I've written on the blackboard here. It's called SF Ratio, and it is written in BASIC. Looking at the program, you see that the individual statements in the program are almost self-explanatory as to what they are going to do inside the computer. For example, statement number 10 will cause the computer to read 2 numbers, which we're going to call S and F. These will stand for the number of students and the number of faculty at Dartmouth. In line 20, we will calculate the ratio R as the quotient of S and F. And notice that the diagonal slash is the symbol that stands for divide in BASIC. In line 30, we cause the value of the student-faculty ratio to be printed out. In addition, we print out some explanatory materials so that this number is properly labeled and we can tell what it is. Line 40 contains the data to the problem. Those two numbers are the numbers of students and the number of faculty members at Dartmouth College. And line 50 is the end statement, which simply tells the computer that this is the end of the program. Now, Mike, why don't you see if you can get this program to work? Turn on the teletype and try typing it in.
Okay, here goes. Professor Kurtz, the computer has just printed out incorrect format in 20. What does this mean?
It means that you have made an error in your typing. BASIC is very friendly. All you have to do to correct that mistake is to retype line 20 correctly. Why don't you try that?
All right.
Most students take the first step toward computer literacy in freshman mathematics courses, while others faced with a problem involving masses of data have to suddenly learn the basics of computer use from a book or from a friend. The terminals at Kiewit Computation Center and more than 70 in other campus locations are kept busy by both students and professors.
What we have here is a program that our freshmen can write, ones who know no calculus at all. It shows the solution to the problem of rendezvous and docking of satellites. Two satellites are in the same circular orbit about 200 miles above the surface of the Earth, and the problem is to send a projectile from one of the satellites to the other one. You'll notice that in fact you have to send the projectile in the opposite direction in order to make it end up at the target. Now, this is something that the astronauts learned by trial and error, and our students solve the problem in fact right here.
The time-sharing system is a working tool in the Department of Classics, too. Here, tapes of the New Testament in Greek prepared in Scotland are being read into the system. Instructor Waite is also using the computer in the study of Latin poetry and prose style, as well as preparing elementary exercises in beginning Latin. At the Dartmouth Hitchcock Medical Center, the time-sharing computer is being used to take the guesswork out of determining radiological dosage for cancer patients. An Alderson contour device determines the outline of the patient. This information is stored on paper tape, along with information regarding the location of the tumor and other sensitive structures in the body. The computer does the number work, and the radiation therapist has an important new tool in the fight against cancer.